Hi there, welcome back. There is this interesting question that I want us to look at. It's coming from grade 11, November 2016, paper 1, Eastern Cape, question 3. I know quite a number of students struggle with this question, but it's a question which is really not challenging. It talks about the nature of roots of a quadratic equation. Remember the formula for the quadratic of solving quadratic equations: x is equal to plus or minus b plus or minus the square root of b squared minus 4ac all over 2a. I believe we do know this formula, and we are interested in this animal which is under the square root. There is 3 instances for this thing. These 3 instances tell us the nature of the roots, or the type of roots that this equation is going to have. If b squared minus 4ac is greater than 0, we are going to have 2 different values for x. But if b squared minus 4ac is equal to 0, we are going to have a repeated root for x, or is going to be a repeated value. X may be equal to -1 or -1, for example. And if b squared minus 4ac is less than 0, that is, if it is a negative number, then we do not have real roots for our quadratic equation. Now, we are being told that we are being asked for which values of m will the equation 2x bracket x plus 1 plus m equal to x have non-real roots. When we say it has non-real roots, we are saying b squared minus 4ac is less than 0, right? So we are saying our b squared minus 4ac is equal to 0. So this equation is going to have non-real roots if and only if b squared minus 4ac is less than 0. Now, for us to be able to determine these values of m, we need to simplify this and write it in the standard notation. So let's expand it. 2x minus x, that's 2x squared, and 2x multiplied by 1, that's plus 2x. The x goes to the left, we say minus x plus m is equal to 0. So our equation then becomes 2x squared plus x. 2x minus x is x, plus m is equal to 0. Now, we want the value of a, the value of b, and the value of c from this equation. Our a is equal to 2, our b here is equal to 1, and our c here is equal to m. From our equation, a is equal to 2. So let's substitute those values into this inequality. That is, our b is 1, so we are saying 1 squared minus 4. Our a is 2, so it's minus 2. And our c is m, is less than 0. 1 squared, so it's 1 minus 8m is less than 0. 1 goes to the other side, minus 8m less than -1. We have negatives here. Divide by -8, divide by -8. So our m, this one becomes 1 over 8. And remember, when you divide by a negative sign or multiply by a negative sign, the inequality changes sign. So we are saying here the values of m which are going to make this equation have non-real roots is when m is greater than 1/8. That is the first question. When you are dealing with this question, generally you should know the nature of the roots. When it is non-real roots, b squared minus 4ac will be equal to, will be less than 0. When it is real roots, real distinct roots, or two different values, b squared minus 4ac will be greater than 0. And when it is equal to 0, it will have a repeated root. And then the second question now, if f of x is equal to root of x plus 2 all over 5 minus x squared, for which values of x is f of x none or not defined? There is only two ways through which this function can be undefined. I think we should be able to see this. The first thing, we cannot divide by 0. If we divide by 0, this thing is going to be undefined. So we are saying the values of x when this is equal to 0. Let's look for those values. Is 5 minus x squared is equal to 0. This one goes to that side. Is 5 is equal to x squared, and put square root to both sides. So we are saying x is equal to plus or minus the root of 5, right? So we are saying if x will be equal to root of 5 or negative root of 5, then this is going to be undefined. And the second instance, remember, we cannot have a negative sign under the square root. So this happens when x plus 2 is less than 0. It becomes negative when it is less than 0, right? So f of x will be undefined if and only if this number under the square root is less than 0, or this number under the fraction equal to 0. So for this one, we took our x squared to the other side. It becomes positive x squared. And then we introduced square roots to both sides. So our x will be plus or minus the square root of 5. And here our x will be greater than negative 2. Okay, mistake there, not greater than negative 2, but x is less than negative 2.